Go forward, do great things to remind your body and spirit. We have how stuff works. I'm going to read the whole article, scan through what you need. Today we're going to talk about what is Wi-Fi and how does it work. There's a time when you only know or find Wi-Fi at certain airports, coffee shops, or hotels. Nowadays, wireless internet connection, also known as Wi-Fi or 802.11 networking, is in just about every home and business. Many Wi-Fi HTM cities are also using the technology to provide free or low-cost internet access to residents. Wi-Fi has a lot of advantages. Wireless networks are easy to set up and inexpensive. They're also unobtrusive. Unless you're on the lookout for a place to watch streaming movies on your tablet, you may not even notice when you're in a hotspot. In this article, we'll look at the technology that allows information to travel over air. We'll also review what it takes to create wireless networks in your home. Contents. First, let's go over a few Wi-Fi basics. What is Wi-Fi? Wi-Fi hotspots and building a wireless network. What is Wi-Fi? Wireless network uses radio waves, just like cell phones, televisions, radios do. In fact, the communication across the Wi-Fi network is a lot like a two-way radio communication. Here's what happens. 1. A computer's wireless adapter translates the data into a radio signal and transmits it using an antenna. A wireless router receives the signal and decodes it. The router sends the information to the internet using a physical wire Ethernet connection. The process also works in reverse. When the router receiving the information from the internet, translating it into a radio signal, sending the computer's wireless adapter. The radios used for Wi-Fi communications are very similar in the radios used for walkie-talkies, cell phones, and other devices. They can transmit and receive radio waves, and they can convert ones and zeros into radio waves and convert the radio waves back into ones and zeros. The Wi-Fi radio waves have few notable differences from the radios. They transmit at frequencies of 2.4 gigahertz or 5.5 gigahertz. This frequency is considerably higher than the frequencies used for cell phones, walkie-talkies, and televisions. The higher frequency allows the signal to carry more data. 2.4 gigahertz connections are now considered somewhat obsolete because they carry lower data speeds than the 5 gigahertz. The 2.4 band continues to see use, however, because the lower frequency can carry over several hundred feet. In ideal conditions, the 5 gigahertz band has a max range of about 200 feet, 61 meters. But in the real world, it is much more prone to interference from walls, doors, and other objects. The 2.4 band may be faster for use connecting a router several rooms away, while 5 gigahertz will definitely be faster for close connection. Wi-Fi uses 802.11 networking standards, which come in several flavors and have evolved over decades. 802.11b, introduced in 1999, is the slowest and least expensive standard. For a while, its cost made it popular, but now is a less common feature as faster standards become less expensive. 802.11b transmits in the 2.4 gigahertz frequency band on the radio spectrum. It can handle up to 11 megabytes of data per second and uses complementary code keying CCK modulation to improve speeds. 802.11a, introduced after B, transmits the 5 gigahertz and can move up to 54 megabytes of data per second. It uses orthogonal frequency division multiple complex, that's OFDM, a more efficient coding technique that splits a radio signal into several subsignals before they reach the receiver. This greatly reduces interference. 802.11g transmits 2.4 gigahertz, but is a lot faster. It can handle up to 54 megabytes of data per second, and G is faster because of the same OFDM coding as 11.11a. 11n, introduced in 2009, is backwards compatible with A, B, and G. It significantly improves speed and range over its predecessors. For instance, although 802G theoretically moves 54 megabytes per second, it also achieves real-world speeds of 24 megabits per second because of network congestion. N, however, reportedly can achieve speeds as high as 140 megabits per second and N can transmit up to streams of data, each at a maximum of 150 megabits per second, but most routers only allow for 2 or 3 streams. 802 period 11 AC came on the scene around 2014. Operates exclusively at the 5 gigahertz frequency. All right, AC is backwards compatible with N and therefore the others too, with the 2.4 gigahertz and the AC on the 5 gigahertz band. It's less prone to interference and faster than its predecessors, pushing a maximum of 450 megabits per second in a single stream, although real world speeds may be lower. Like N, it also transmissions from multiple spatial streams, up to 8 optionally. It's sometimes called 5G because of its frequency band, sometimes gigabit Wi-Fi because of its potential exceedingly gigabit per second, multiple streams, sometimes very high throughout. That's BHT for the same reason. AX, Alpha X-ray, also known as Wi-Fi 6, came into the industry in 2019. The standard extends the capabilities of AC in a few ways. First of all, the new routers allow even higher data flow up at 9.2 gigabits per second. Wi-Fi 6 also allows manufacturers to install many more antennas on the router, accepting multiple connections at once without any worry of interference or slowdown. Some new devices also connect on a higher 6 gigahertz band, which is about 20% faster than ideal conditions. BE, Bravo Echo, or Wi-Fi 7 start rolling out in 2024, offering better range, more connections, and faster data rates than any of the previous versions. All right. Other 802 standards focus on specific applications of wireless networks like wide area networks, which is WANs, inside vehicles, or technology that lets you move from one network to another seamlessly. Wi-Fi radios can submit and transmit on any other frequency band, or they can frequency hop rapidly between the different bands. Frequency hopping helps reduce the interference in multiple devices using the same wireless connection simultaneously. As long as they all have wireless adapters, several devices can use on one router continuous on the internet. The connection is convenient, verbally invisible, and variably reliable. However, if the router fails and too many people use high bandwidth applications and time, the user can experience some interface or lose their connections. Although newer, faster standards like AX will help with that. Next, we'll look at how connections to the internet from a Wi-Fi hotspots. Building a connection, Wi-Fi access, WPA, media access as well.